So here we are going to see that this is my desired signal and I have an image signal which is essentially a noise located here at a frequency far away from the omega RF. And you see here the local oscillator is exactly located here in such a way that on either side it has the image frequency. So I can say omega LO, from omega LO, the message and the image signal are equidistant by a frequency omega IF. In this condition, if this scenario happens, when I'm going to mix here, you can see that this omega IF is going to be mingling with your desired signal. So you know when you mix two signal, when you multiply two signals, the frequencies will be additive and subtractive, right? So same way, so when you are going to have this signal is going to be mixed with this omega LO, we are going to have this signal, additional signal omega image, which is going to be 2 omega LO minus omega in. So omega, you can see from this, you can see that omega Im minus omega In is going to be equal to 2 omega If. So separation between the frequency of image and desired signal is 2 times the image signal. So that when you mix this signal and this signal, I will get it as the image frequency is going to be 2 times omega LO minus omega in. This 2 omega LO minus omega in is going to fall directly inside your desired signal. So you see that before mixing, the image was far away, but after you mix, the image is going to come into your band. So your signal is getting mixed with your image, which is unwanted for you. So this will cause a huge issues in the receiver. Okay, so what creates an image when this condition is satisfied? That image is going to fall in band with your desired signal. So always omega, when the image frequency is going to be 2 times omega LO minus omega in, this is going to be the reason for your image signal. And what is the consequence of image signal? It might look away from the signal before mixing, but after mixing, it will interfere with your signal and it will finally corrupt your signal. So down conversion of a signal with image will result in corruption of desired signal after down conversion. Okay, so this image frequency, the relation between image frequency, desired signal, and omega LO is here. If this is not satisfied, then no issues. Image will be somewhere far away. Even after mixing, desired signal will be here. The image signal will be somewhere here. If I use LPF, this image will be completely cut off. It will be completely filtered. So no issues will be there. But when this mathematically, when all these three frequencies are related by this equation, that causes an image which you cannot do anything to stop the image from mixing with your signal. So the each you have Bluetooth, you have Wi-Fi, you have WiMAX. So all the wireless standards, they use their own techniques to suppress the image. So image power will be always higher than the desired signal. You can see the magnitude. Image power is very high compared to desired signal because it is noise, right? So when you mix this noise with your desired signal, it will try to dominate. So we have something called as, we have to have proper image rejection algorithms or circuits inside the receiver to combat the high power dominant nature of your image. Okay, so wireless, it plays a very serious issue because you have a lot of users within a single base station, right? So when everybody start speaking in a call, each one will become an interferer, and each one will be using a frequency slightly away from the each other, right? So that means if n people are speaking, n minus 1 interferers you will have. Except that person, everybody will look like interferers. So that is what is the